Hello, my name is Luke Lawson, BICSI U.S. Western Region Director. Thank you for joining us for Driving the Customer Conversation, How to Talk Wireless with Your Client. Our presenters are Mark Nihas and Scott Rahim. Mark Nihas is Midwest Area Vice President for Connectivity Wireless. He has more than 25 years of ICT installation, project management, and sales and marketing experience. An RCDD since 1997, Mark has presented to BICSI fall and winter conferences, several region BICSI meetings, and numerous customer-specific seminars. He is a published author and regular contributor for various industry trade magazines. Scott Rahim is a national solutions engineer for connectivity wireless solutions. He applies in-building wireless knowledge to ensure best in-class system design, performance, and consistent RF engineering for enterprise clients. With project experience spanning several industries, Scott has designed, engineered, commissioned, and managed some of the nation's most complex venues while providing extensive customer support throughout the duration of each project. Ladies and gentlemen, please welcome Mark Nihas and Scott Rahim.
Hey, good morning, good afternoon, good evening. Thanks for joining Scott Rahim and myself, Mark Nihas, for our BICSI session, Driving the Customer Conversation, How to Talk Wireless with Your Client. We're excited that you can join us. So for the next 50 minutes or so, what we're going to talk about is a wide range of topics. In a way, we're going to go all over the board, but we're going to try to encompass everything that is in the wireless world that we might need to think about as it relates to the BICSI community, as it relates to coverage and capacity, as it relates to new buildings, existing buildings, anything that you're doing with your client. So again, a very broad conversation, but one that we hope is helpful from the standpoint of, again, let's all be more proficient and effective in wireless conversations with customers. I think there's a lot of people in BICSI, like myself, who started out in this industry from a cable perspective when wireless was not what it is today. But if we needed connectivity, we needed a cable to a device. So understanding the world and the changing aspect of this world, I think is really, really critical. Scott and I are excited to share these ideas with all of the BICSI community. So when we created this presentation, we tried to think of it again through the lens of BICSI. If I'm an RCDD, perhaps, I'm involved in design, I really want to know all this stuff. I want to know it so that I can include maybe a greater scope in terms of what I'm doing with my customers. I want to understand from a design perspective, hey, if I'm putting in a fiber backbone that's serving everything here, that's serving LAN and wireless and building automation and security, what do I need to know for fiber? What do I need to know about service providers and what kind of space might they need if they're putting in a DAS or putting in a small cell? So we need to understand all those things very well to have good conversations and give good advice to our clients. If I'm a BICSI project manager, I might be interested in these topics because I want to understand, hey, if there's a DAS scope, what other steps that I'm not used to might be involved? What other coordination might be involved? If there's DAS public safety, what coordination with AHJs? How can I manage all these scopes at the same time for the betterment of my customers? Again, doing more scope, more services, making sure I'm proficient and I can deliver on a project. And again, if I'm in business development, if I'm seeking new customers, I want to again provide clarity and conviction that I know what I'm talking about as it relates to wireless, that I can give good advice, and that my company is competent. So those are all the things that we kind of are thinking about as we're talking through this. And when we think about our customers, right, we all have a variety of customers. And I think typically a lot of people look at the end user and think of that person as oftentimes the most technical, but not always, right? You might have a customer who's very proficient in LAN, but he really doesn't understand public safety, right? And how that world works. So differing levels of technical expertise by our end user and how do we communicate with them? They may be super familiar with Wi-Fi, but know nothing about cellular, for example. So when we're dealing with a general contractor as our customer, maybe it's more focus on price in some cases and more focus on delivering the scope and delivering it on time. And what I see when we're involved in projects from a general contractor is really good coordination. They're driven by efficiencies And if we can coordinate the same cable and pathways at the same time for all these systems, all these low voltage and wireless systems, there's benefit to the general contractor, right? There's benefit to the owner. So being able to explain that helps all of us. Oftentimes we're working with an ICT consultant as our customer. So there's someone who writes a specification, product specification or performance specification. And that ICT consultant, oftentimes they're the one saying, hey, what's my roadmap here with this technology? What is the upgrade strategy? I don't want to recommend something to this client and then a year later it's obsolete. So oftentimes the ecosystem points to this guy, that ICT consultant, who's in many cases an RCDD. Hey, make sure you future-proof this. Make sure this is something that I can live with for 5 years, because I don't want to come back to you in a year or two saying, why didn't you suggest this path? So that's something to think about in our interactions with our customer base. And then the electrical contractors, oftentimes our customer. They too are focused sometimes more on price than others, and scope and coordination. Hey, how can I put in pathway and spaces the most efficiently to serve everyone, right? So those are the things we think about as we think about talking to our customers in the wireless world. And so where do we start? In my mind, this is the best place to start. If you're curious about wireless, if you're interested, do what I did a few years ago when I really got into wireless, and I downloaded this and put it in my office. And like a kid opening an encyclopedia, you just look at it and go, okay, I didn't really understand that this is what this low frequency is, and this is what people call LMR or land mobile radio, and oh, over here's the gigahertz that we're going to talk about today, the super high frequency. So it's pretty enlightening to look at this, and I think it will help everyone just gain a greater understanding of what is spectrum, who owns it, who controls it. And again, in the US, it's the FCC. Not every country has the FCC. So the FCC is a great thing in terms of being able to control, allocate, and direct spectrum. So when we think about wireless for our building, whether it's a campus, a hospital, a school, any type of building or structure or development, I really think you can break it down into 4 main classes of wireless. The first class is called low-rate wireless personal area networks. And this is specified by the IEEE. This is stuff that most of us are familiar with. The more common names are Bluetooth and Zigbee. The less common names are listed. So there's probably 15 or 20 different classes or brand names for wireless in this arena. And this is important for us to know. Why? When people talk about growth in IoT devices and connectivity, a lot of people assume it means cable and connectivity and fiber, all the systems we do. This really doesn't apply to us. With these devices, these networks are typically mesh networks. They're low power, meaning you can just have a battery. I don't need to provide power. That battery could be for 2 years, 5 years, or 10 years, or I could have a little connection for solar and have it live forever. So they're very self-sufficient. No power needed, no connectivity. How do they connect? In a wireless mesh network in the same room. So think of lighting sensors. Think of these things embedded in cameras. Think of temperature monitoring. All of these things are important to IoT, but we as BICSI professionals are not involved because they're built in with the devices. But they are very critical to our customers' IoT strategy. So this is the first class. And then you could talk about the second class being unlicensed frequency, unlicensed spectrum. And what's good about this is anyone can use and configure. And what's bad about it, as we'll talk about, is anyone can use and configure. So what's good about unlicensed? It's easy to hook up. It's familiar. Most of what we're talking about is Wi-Fi. And I think when we think about Wi-Fi for our buildings today, as BICSI professionals, we've come a long way in, say, 5 or 10 years. Wi-Fi today is a primary network for a lot of people. It didn't used to be that way. Wi-Fi has become ubiquitous. Wi-Fi has become very much mainstream in terms of people using it in an office environment or any type of building environment. And it didn't used to be that way. So we'll talk at the end about Wi-Fi 6 and 6E and how great they are. But when we think about wireless, there's Again, a wide variety of approaches here, but if we base our discussions on proper design parameters, educating our clients about Wi-Fi 6, and providing the right deliverables in terms of design and help with our OEM partners, that's where we can be successful with Wi-Fi. So the third class of wireless that we need to kind of think about is license frequency, license spectrum. This is spectrum that is owned or leased, if you will, by these service providers and others. I note Dish here. Dish will be the next service provider on wireless networks. So mainly cellular. And when we think about license, we need to consider someone else owns this spectrum. Someone owns this, and we're not able to change the spectrum or interfere with it or retransmit the spectrum without their approval. So what we run into in the BICSI world, in the ICT world, is oftentimes we don't understand the parameters of the wireless carrier, what their steps are, what their requirements. We might waste a lot of time and effort doing in-building wireless. So we've got to really answer to them in terms of we're retransmitting their signal. We've got to know what they want. We've got to follow their steps. And I think most importantly in this presentation today, Scott will talk at length after I'm done in a few minutes about what's new and exciting, what we call the mid-band spectrum, C-band, and millimeter wave. And what do we need to understand about that for in-building? And the fourth and final class that you could categorize in-building wireless is public safety. A lot of us in the BICSI community have been working in the public safety arena for 10 plus years. And if you think about it, where did it originate? Kind of originated with 9/11. So the 9/11 Commission's last recommendation was related to wireless and where we're at today. It was, we need to make sure that emergency responders, first responders, firefighters, all of those people, that their signal, that their radios work in buildings. And then second, we need interoperability. So radios didn't work in buildings, and different agencies or entities couldn't communicate during an emergency. And one of the biggest things that came out of that was a public-private partnership called FirstNet. FirstNet is a $25 billion investment by AT&T where they're sharing that spectrum and allowing a 700 megahertz or band 14 signal to be transmitted. So the good thing about this is it's nationwide. Not everyone has adopted it, but it's gaining daily, and it's a great example. Interoperability, and it's public safety, but it's also cellular. In fact, it is cellular. It's band 14. It's an LTE technology. So these are all things that we all kind of need to think about when we're thinking about public safety. I think a lot of us are very proficient in understanding the process of, hey, we don't know if this building is going to require augmentation or not. We won't know until we build it. So what do we do really to mitigate risk for our client? What do we do in terms of intelligent design? Number one, we budget for this. We make sure there's a placeholder in case it's needed so the client's not surprised. And then number two, we think it's pretty intelligent to plan for pathway and space. So the idea is, hey, I might need a system. I don't know, maybe I won't know until the very end, but let's make it easy to install. So I'll make sure that there's conduit, there's pathway, there's a space to put equipment, there's an electrical plug-in, and then just really understanding the AHJ and what the requirements are ahead of time so we can plan effectively, understanding what benchmarking is. All of these things are important, and it can include all of the frequencies listed on the left. 150 megahertz, typically still in force in California in many places, as is 450, 700, 800, less expensive, and being adopted more and more for new jurisdictions. And then one last thing on public safety. All of this is based and predicated on when we're building new buildings of a certain size, we need to make sure that radio works, right? Well, it's come to the realization that first responders don't want to be picky about buildings. They don't want to just go in new buildings and say, I'm safe here. They want to go in old buildings and say, I'm safe here. What we mean by that is there's some direction in codes calling out for emergency responder radio coverage in existing buildings. So for those of you who live in Florida, this has been law for at least a year. So they're giving a couple years for buildings to come up to code, but we're seeing more and more interest from AHJs, first responders saying, really, every building should be safe. This is a benefit for all. And with that, it also includes cellular, right? We need cellular connectivity because what happens when you have an emergency? You grab your cell phone. All these things are good things to think about with our new buildings. And then when we're speaking about deployment, what do we need to kind of realize as BICSI project managers, RCDs, professionals? What are other steps? So these are all typical steps for any project, right? But like number 3 and 4 are probably some additional steps when we talk about, I need to coordinate with the AHJ for this public safety walk so he can come and do his radio test. Or I need to, number 4, I need to negotiate with that wireless service provider to fund this DAS, or I need to negotiate to have them come in and provide signal source at the right time and really have overall project success and make my client happy. I need to commission some additional equipment that I didn't have to do before, and I need to follow a certain process so that maybe an AHJ or a carrier will buy off on that. So those are all things that we need to kind of think about and consider as it relates to wireless. With that, I'm going to turn it over to Scott for 15 or 20 minutes on what is new for C-band and other technologies.
All right, thank you, Mark. So now we're going to dive a little deeper into C-band. The main points I'm going to hit on today are, what is C-band? I'll provide some general and background information on it. We'll talk about how are the carriers planning to deploy C-band and where. And we will also talk about the purpose of C-band and why C-band is needed. So the spectrum highway is changing. Today, carriers' networks mostly operate on 600 to 2500 megahertz frequencies, with frequencies below 1000 megahertz being considered low bands and frequencies between 1000 and 6000 megahertz being considered mid bands. That said, in order to accommodate current and future data traffic growth and also to support mid-band 5G, new mid-bands are becoming available for usage. And these new mid-bands are CBRS, C-band, and also 3.45 gigahertz. So in terms of bandwidth, the CBRS will provide us with 150 megahertz of bandwidth. C-band will provide us with 280 megahertz of bandwidth, and 3.45 gigahertz band, which we don't even know what that's going to be called yet because it was just announced recently by the FCC, but it's supposedly the auction for it is going to be in September, maybe October of this year, but the 3.45 will provide us with 100 megahertz of bandwidth. So to put this into perspective, the CBRS band alone will provide us with more bandwidth than how much PCS and AWS bandwidth Verizon or AT&T have today. And so these new mid bands, they're going to provide us with a lot of new spectrum that's going to provide us with a lot of capacity to support 5G in the mid bands, and it's going to enable noticeably faster throughput speeds and reduced latency or faster response time between your device and the network. For Wi-Fi, we're still operating on 2.4 and the 5 gigahertz bands, even with the new Wi-Fi 6 technology. That's until Wi-Fi 6E starts getting rolled out, which will open the doors for the 6 gigahertz band for the first time ever, but that's for another presentation. As for millimeter wave, the carriers have been deploying mainly the 28 gigahertz and the 39 gigahertz bands to support 5G in the high bands. And as you can tell, there's a lot more spectrum or bandwidth available in millimeter wave than low and mid bands. You have about 850 megahertz of bandwidth available in the 28 gig band and about 1400 megahertz of bandwidth available in the 39 gigahertz band. And for that reason, this is why you see much faster throughput speeds, a lot more capacity, and lower latency in millimeter wave spectrum or high bands 5G than the low and mid bands. So with that, how do we prepare for mid-band 5G, or how the carriers are going to start supporting mid-band 5G. And the answer to that is they're going to start with the 1900 and 2100 bands first, which all the major carriers already have a lot of LTE deployments on it today. They will likely start converting their LTE technology on one or both of these bands from LTE to 5G NR, just like how they started converting the UMTS or the CDMA technology on 1900 megahertz at several sites to LTE when LTE first started getting rolled out. T-Mobile, they're also deploying their 2500 megahertz spectrum that they recently acquired from Sprint to support their 5G NR. And that at some point in the near future, we do expect carriers to want us to add CBRS, C-band, and or 3.45 gigahertz to existing networks and also to new networks to support capacity, additional capacity where it's needed. And so this is why it's crucial that whenever we're designing networks today, we take these new mid-bands into account to avoid challenges that come when we want to add them later on. So here we see the estimated sub-6 gigahertz spectrum holdings following the recent C-band auction. We also see the estimated number of subscribers each carrier has, and that's indicated by the number above the bar graphs, and we see the estimated number of macro towers or cell towers each carrier has, as indicated by the number below the bar graphs. So from this slide, you can see that Verizon invested heavily this year in their C-band spectrum that's highlighted in the red block. And they also purchased a significant amount of CBRS spectrum as highlighted in the turquoise block. To me, this is a strong sign that Verizon is planning a lot of network deployments to support their mid-band 5G and these two new bands, especially C-band. AT&T and T-Mobile, they also purchased a significant amount of C-band, more so AT&T than T-Mobile, but still not nearly as much as Verizon. And this is because T-Mobile, they have 194 megahertz bandwidth on their 2.5 gigahertz band, which provides them with a lot of capacity to support mid-band 5G. And AT&T, they have their WCS or 2300 megahertz band to aggregate with their PCS or AWS to help support their mid-band 5G. We also see additional carriers in the slide like Dish and US Cellular. Dish purchased a significant amount of CBRS spectrum last year to roll out their 5G. And the US Cellular also purchased some C-band and a little bit of CBRS. And we have cable companies like Comcast and Charter who also purchased a good amount of CBRS spectrum last year to enter the wireless space. So what can we expect from these new mid-bands? So when it comes to CBRS, in addition to providing more capacity to support mid-band 5G, CBRS also opens up new opportunities for organizations to deploy their own private LTE or private 5G networks. That way they have more control over their data, more control over their networks, and they can also provide more secure, more reliable connectivity to devices that traditionally relied on Wi-Fi. And so by that sense, the CBRS network will also help offload congested Wi-Fi networks. And so to me, a great use case of CBRS is to essentially place all of your back of house operations devices, your building's IoT and smart technologies on the CBRS network for the more secure, more reliable signal, and maintaining your Wi-Fi's bandwidth for your visitors and your tenants' devices. In terms of market penetration for CBRS, we're still at about 20%. And so we still have some ways to go before the majority of the devices in the market can connect to the CBRS network. That said, that number is increasing year over year as newer devices come out each year. And the majority of the newer devices have the capability to connect to the CBRS network. And so most of the new phones, new tablets, new laptops, they can connect to CBRS. C-band, The auction for it just took place in February this year. And as I said in the last slide, Verizon and AT&T came out big winners, especially Verizon. And we do expect the carriers to start deploying C-band starting early next year. And just like CBRS, most devices, they can't connect to C-band just yet, but the newer phones can. Now, millimeter wave, there are 4 major millimeter wave bands that the carriers own, and they're the 24, 28, 37, and 39 gigahertz. And we have approximately 5.5 gigahertz of bandwidth across these 4 major millimeter wave bands. And Verizon currently owns blocks on 28 and 39 gigahertz. AT&T owns blocks on 24, 28, and 39 gigahertz. And T-Mobile owns blocks on 24 gigahertz. Just like with CBRS and C-band, most devices can't connect to millimeter wave, but newer ones can. Lastly, the 3.45 gigahertz band, the auction for it is scheduled for September of this year. It may get pushed out to October, we'll see. But it does seem to be targeting other companies outside the major carriers like Comcast and Charter. And this is likely because the new 3.45 gigahertz frequencies, they can't be combined as easily as with the recently provided C-band frequencies. Okay, so what else do you need to know about C-band? C-band is being split into 3 blocks: A block, B block, and C block. A and B blocks will have 520 megahertz channels. C block will have 420 megahertz channels, giving us a combined total of 280 megahertz. And following the recent C-band auction, Verizon now owns an average of 161 megahertz of spectrum in each of the major markets. AT&T owns an average of 80 megahertz of spectrum in each of the major markets, and T-Mobile now owns an average of 27 megahertz of spectrum. But just because the carriers now own the spectrum doesn't mean they can start deploying on it just yet. Essentially, the FCC is going to have to clear the spectrum before the carriers can start utilizing those frequencies for C-band deployment. What I mean by that is right now, the C-band spectrum is being utilized by several satellite companies for television and radio broadcasting throughout the United States. And so in order to support 5G in the mid-bands in the United States, the FCC decided to reallocate a portion of that C-band spectrum, specifically from 3.7 to 3.98 to the telecom companies. But again, before they can start operating on that, the satellite companies will have to move their operations off the repurposed spectrum. And this is being done over 2 phases. And so to incentivize the satellite companies to move their operations faster, the FCC is offering them $10 billion if they clear 100 megahertz of A block spectrum by December of this year. This is phase 1, and the remainder of B and C blocks by December of 2023, and that's part of phase 2. So here we see Verizon C-band deployments in phase 1. Those are the 46 major markets, and the picture on the left. And we also see in the picture on the right, Verizon's final block assignments as it relates to C-band after phase 2 is complete. And so it's just basically showing how much spectrum they're going to own in each market and which block. And this side, this is just like the last one, but it's showing AT&T's C-band deployment in each of the major markets. In the picture on the left, same major markets as Verizon. And in the picture on the right, we see AT&T's final block assignments and all the markets. And again, we see which blocks they're going to own in each market and also how much spectrum they have in each market. And here we have T-Mobile's final C-band assignments. As you can tell, they're not going to have C-band in every market, and T-Mobile is not going to start deploying C-band until 2023. And I'll get to why in the next slide. So Verizon purchased a good chunk of A block, but since B and C blocks will not become available until much later, relatively later, And AT&T also needs C-band in order to accommodate their mid-band 5G. The FCC decided to split or they decided to share the A block C-band spectrum between Verizon and AT&T in a 60-40 split, where Verizon will get 60% of the A block spectrum in the phase 1 deployments, and AT&T will get 40% of A block spectrum. That way they both can start deploying C-band next year. Once B and C blocks get cleared, AT&T will relocate to their B or C blocks depending on the market, and T-Mobile will start deploying their C-band spectrum. T-Mobile didn't purchase any A block licenses, and also, like I said earlier, they have their 2.5 gigahertz spectrum that they can currently use to support their mid-band 5G. And so for those reasons, T-Mobile right now just doesn't need the C-band spectrum as much as AT&T and Verizon, so they're not going to start deploying until their blocks become available. So in terms of our propagation characteristics, C-band is considered a capacity solution, not a coverage solution. And this is because C-band frequencies, they're not going to propagate as well as low bands or other mid bands like 1900 and 2100 megahertz. So to put this into perspective, C-band frequencies will propagate about 9% of the distance that usable 700 megahertz signal can travel, and about 25% of the distance that usable 2100 megahertz signal can travel. And so in order to get C-band signal to propagate all throughout a venue, you would need higher output power from each antenna, and you would also need higher antenna density and more remote amplifiers throughout a venue. And as you can imagine, this can drive up the cost of your system significantly. And so it just doesn't make sense to make that kind of investment for venues that are not capacity driven, but just need some basic coverage. As for millimeter wave, it will travel about 0.3% of the distance that usable 700 megahertz signal can travel. And so, as you can imagine, you would need an extremely dense design to get millimeter wave signal to propagate all throughout a venue. And this is why I still maintain that when it comes to the business as usual venues like an office building or a hospital, I don't think the carriers would want to propagate millimeter wave signal all throughout the venue. I think carriers will still want to deploy millimeter wave 5G in specific high traffic areas or areas that require low latency when the millimeter wave signal is required for an indoor deployment. So we talked about what is C-band, and we talked about the purpose of C-band. Now we're going to go over how the carrier is planning to deploy it. Again, C-band is a capacity solution, not a coverage solution. And so from a DAS perspective, the carriers will likely follow a similar approach that they used for millimeter wave 5G. And that is, they're going to start deploying it in high capacity venues first, like stadiums and arenas. And in fact, SoFi Stadium, which is the official Super Bowl 2022 venue, has already received funding from all the major carriers for C-band deployment. It's the first and only venue so far to receive funding for C-band deployment. Business as usual venues, they're not yet budgeted, but they'll come later if the capacity is needed there. And from a macro deployment perspective, they're going to start deploying the major markets first, like I showed in previous slides, and they'll likely start deploying 64 by 64 or 32 by 32 MIMO. And they'll also install some small cells to help close gaps in certain areas and high traffic outdoor areas where cellular signal from the cell phone tower is not reaching very well. And also from indoor coverage deployment perspective, there's talk that they would want to deploy in 4x4 MIMO configuration, meaning we would pull 4 cables to every antenna, but that would depend on the venue type and the capacity needs. Lastly, from a RAN perspective, the carriers are still expected to continue their partnerships with Nokia, Ericsson, and Samsung to provide the signal sources such as baseband units and radio heads. In fact, Verizon has already established agreements with Ericsson and Samsung to provide these signal sources. And now I will give it back to Mark.
Hey, thanks, Scott. So what are some practical takeaways? Let's spend a few minutes just talking about different technologies and having an open dialogue. So let's talk about small cells. As an integrator who's been involved in wireless for well over a decade, we're asked all the time, hey, what do I need here? Do I need small cell? Do I need a repeater? Do I need a DAS? Should I do Wi-Fi calling? There's a lot of confusion about these different technologies. And with small cells, let me just say, small cells are fantastic. Small cells are a great solution. We recommend small cells daily. And we recommend them for the place where they fit. Do you have a small area? Are you just mainly concerned about one carrier? If so, this is perfect. What we see in the BICSI community when customers are asking these same questions, people often gravitate to them because of their cost. I'll give you an example. We'll talk about one specific product, the AT&T Metro Cell. It's a great product. You can Google that. You can pull down all the information I'm going to tell you, including the installation guidelines and parameters. But for example, like all small cells, the AT&T Metro is designed for a small space. They say this is perfect for 15,000 square feet. Oh, you have a bigger space? That's okay. You can daisy chain them. You can connect them, 3 of them, 45,000 square feet. Beyond that, no, it won't work. So when people use this strategy in a big building, they run into a lot of interference issues and a lot of it not working correctly issues. So what's good about it is it's inexpensive. 15,000 square feet for $5,000, I think. I think that's 33 cents a square foot. And you can self-install it. And if you don't want to self-install it, you can pay them $1,500, they'll install it. But again, these are great for small space, for single carrier. Again, what we see for people employing a wireless strategy for cellular is, hey, let's get small cells for every carrier. So if you add those all up and go, well, I need a small cell for T-Mobile, I need a small cell for Verizon. Sometimes you need another small cell for a different frequency. So they're single frequency, single carrier. They're not intelligent, they don't interact. What happens if there's problems with a small cell? What does the installation guideline say? Move it a little bit and try it then. So again, it's great for a small space. It's great for single carrier. Doesn't make sense for big buildings. And I think that's an important thing to realize. And then the other thing that we want to talk about in the wireless world is how do we get cellular connectivity into a building? So if we go back to small cells, it's a very effective, cost-effective way. You just plug into an internet connection. That is what makes it so easy. The wireless carrier with a small cell is going to bring wireless in and out over the right size internet connection. Well, if we don't use small cell, we could use an antenna on the roof or a repeater or something else. Is that a good solution? People have done that for years. And I think whether it's an end user or an integrator, just not having the knowledge or realization that if you do that today, you're going to disturb the carrier's macro environment. So they may shut it off, right? There's FCC requirements that you have to register this. And if it's done incorrectly or if it impedes their outside or macro signal, they'll shut it off. I think the real takeaway here is fiber optics, right? That so much of us have worked through in our career. Fiber optics continues to be mission critical. So today we're saying for large venues, for large active DAS and other solutions, we're going to bring in the wireless via fiber. So we'll bring it via fiber. The carrier will provide it into their BTS or their radio, and it'll connect. And why do we do that? We have unlimited capacity. So the stealing signal from the air gives you nothing in terms of capacity for all the users, may impede the macro. It's not really fit for large scale type of installations. And then lastly, I want to touch on Wi-Fi. So again, Wi-Fi from, hey, we'll have it as a courtesy, as a backup, to Wi-Fi is going to be my primary. And I want to know about Wi-Fi 6. What's the difference between Wi-Fi 6 and 6E? And, what are the benefits? So really, I'll just go through Wi-Fi 6. Couple key things that that have really improved it, made it much better than previous versions. The first one is called OFDMA, and that's simply a scheduling technique that drives a massive reduction in latency, from 20% to 90% reduction in latency because of OFDMA. Why is that important? Latency is important for video streaming, for gaming, for real-time applications, for what we're doing right now, right? So that it's a pleasing visual experience. There's no lags, there's no skips. So that greatly improves latency for Wi-Fi 6. The next technology is called 1024 QAM. And what that is a modulation scheme in which what they call carriers, two carriers or signals that are shifted in phase by 90 degrees are modulated. And by modulating, they're able to greatly improve the data capacity of Wi-Fi 6. It's really more bits per hertz is what it comes down to. And then another technology development with Wi-Fi 6 is BSS coloring. And it simply refers to a mechanism to mark each BSS or basic service set to differentiate it. So when you think about Wi-Fi, it's a one-to-one connection from sender to receiver, one connection at one point in time. And if multiple devices are competing for that to connect, we have contention, turn away, retransmit. What BSS or basic service set does is color each communication, if you will. I want to talk to Scott. My color set is going to be blue, and that way there's not the contention I can identify. And over here is red, green, orange, and yellow. So BSS is a great technology that's driven Wi-Fi 6. And what is Wi-Fi 6E? So if you look on the right, it kind of lists some of the different things with Wi-Fi 6E. Suffice it to say, Wi-Fi 6E is everything that Wi-Fi 6 is, but it's only for 6 gigahertz. So it's a huge amount of capacity. When Scott has talked about spectrum and what this piece means, 1200 megahertz. So a huge superhighway. And it's a superhighway because they don't allow old cars on it. It is not backward compatible. Your device must be Wi-Fi 6E. There are no junkers allowed on that highway. So not only huge amount of bandwidth, but there's nothing else to slow it down but other efficient Wi-Fi 6E devices. So lots of exciting developments there in the Wi-Fi world. Really in summary, I think it's incumbent upon all of us as BICSI professionals to share forums such as this. There's a wonderful variety of education out there, primarily BICSI, but in other like industries, manufacturer training, things like that. And that's why we're here, right? To share information, to share ideas and share best practices. Why? It's better for us. It's better for our clients. We grow and we learn. So with that, again, please contact Scott Rahim or myself, Mark Nias. We're glad to answer any questions, have a follow-up, and thank you for joining today. Have a great day.